I've been doing a ton of work with convolutional neural network layers as of late, namely around building generators for GAN architectures. So I'm trying to build super resolution models and models that are able to remove smoke from different types of images. One of the techniques that I found ridiculously useful when it comes to working with CNNs is taking a look at the outputs from intermediate layers, aka taking a look at what CNNs see. We're going to take a look at exactly how to do this in this tutorial. Let's do it. What's happening, guys? My name is Nicholas Renaud, and in this video we're going to be taking a look at what CNNs see. So rather than taking a look at a fully trained CNN architecture or deep learning architecture that uses convolutional neural networks, I'm going to show you how to strip that back and take a look at the outputs from each set of different CNN layers, as well as maybe max pooling layers. This is ridiculously useful, particularly if your deep neural network isn't quite outputting what you're expecting. You can actually take it a little bit further back and see what is happening at each stage of the deep neural network. These are the types of architectures that you tend to encounter when you're building really sophisticated models. So if you're working with GANs or you're working with object detection models, this technique will probably help you. Ready to do it? Let's get to it.
Alrighty guys, so we're going to go on ahead and take a look at what CNN layers see. So if you haven't heard of CNNs before, it is a convolutional neural network layer, and it is a common deep learning hidden layer or intermediate layer that you typically use for image-based processing or spatial data. So what we're going to be doing is we're going to be taking a pre-existing model and we're going to see what the specific intermediate CNN layers see. This is something which I found ridiculously useful as of late. So a couple of times this morning or a couple of times this week, I was actually trying to work on some GANs that I've got coming up for future tutorials, and I was getting output from the generators which were just a black image, and I'm like, well, hold on, something has gone terribly wrong here. Either that or I have no idea what is happening. So using this technique has actually been ridiculously helpful in terms of sort of debugging and taking a look at what the CNN is focusing on, whether or not we've even got the right outputs and the right activations. So rather than just stepping through a Jupyter notebook like I've been doing lately, we're actually going to write this one up from scratch because that's kind of how I prefer doing it. And let me know in the comments below if that's sort of what you prefer as well. Now, we are going to be picking up where we left off from the image classification tutorial. So if you want to pick that one up, I'm going to link it somewhere up there, and I'll probably throw it down in the description below. But if you actually take a look, we actually went through and built an entire image classification model. So the link is at github.com/nicknocknow/image classification. So you can actually pick that one up there. And all of the code and data and models, I believe the models are there. Yeah, so you've actually got this image classifier H5. So I've actually linked the final trained model. Now I've called it something else in this tutorial. I think it's happy sad classifier, but you could pick up this H5 and do it with through the exact same process that we're going to be going through today. So let's actually kick this thing off. So the first thing that we need to do is import a bunch of stuff. We are going to first up import itertools. And this is really going to be used to actually loop through the outputs of CNN. And it just makes it a little bit easier to visualize in a grid pattern because we're going to use matplotlib in a sec to actually visualize that. So let's import matplotlib. So we're going to use that to do some viz. So matplotlib is going to be used, and specifically we're going to be using the plot.imshow function to actually visualize the outputs from the intermediate CNN layers. We are also going to need OpenCV and NumPy. Right, so we've imported OpenCV there, import OpenCV, and we're really going to use that to open images with Python. And we're going to bring in NumPy as well, and NumPy is really going to be used. I think we're just using the expand dims function. So this like wraps an array inside of another set of arrays. So you'll see that in a second. So that's OpenCV, that's NumPy. We're now going to need a bunch of stuff from TensorFlow. So import TensorFlow as TF. We're going to need the sequential model. So import, actually it's going to be from TensorFlow.keras.models, import load model, and we're also going to need the sequential API. What have we done? Import, we spelled this wrong, TensorFlow. Cool. All right, so we've gone and brought in a bunch of stuff there. So the last two lines that I wrote were import TensorFlow as TF, and then from TensorFlow.keras.models, import load_model and sequential. Let me just double check we got everything. That is looking pretty good. All right, cool. So TensorFlow is going to be used as our main deep learning architecture. So main DL architecture. And we also need the load model function, and the load model function is going to be used to load up that H5 class that I had there, or the serialized model. Now I've got it called here. What do we got it called? Happy sad model.h5. Really great naming, Nick. But anyway, you sort of get what it is. The deep learning architecture, or the deep learning model that we're going to be using, is an image classifier, and it classifies people as either happy or sad. So, I mean, maybe good work, Nick? I don't know. Sequential is going to be used in a really unique way. So what we're going to do is, once we've loaded up that H5 model, right, we're actually going to specify which intermediate layers we want to bring in. Now, we can actually use the model.summary function to visualize what layers are actually available. So you'll see that in a second. So this is going to be for modeling over here. Cool. All right, so we've got those now imported. The first thing that we actually want to do is actually load up our model. So we can type model equals load underscore model, and then we just need to pass through the path to the H5 file. So let's say, for example, you're doing this with a different H5 file. You just need to pass through the path to your specific H5 or serialized model. So we are going to load up the existing trained model here. And if we actually take a look, you can see it is called happy sad model. So we're actually going to pass through, and that's inside of a folder called models. So this is my base or root folder from which I'm working on. This is the the Jupyter notebook that I'm currently working on, CNN layers.ipynb, and I'll make all this code available in the description below as well, so you can pick this up if you want. So what are we doing? We're loading up our model first. So ./models/ what's happy sad model.h5. Cool. So this will actually load up our existing H5 model, right? So it's going to go into here, it's going to grab this H5 file, and it's going to load it up. So if I run that, you can see that that's loaded successfully. If we type in model, you can see it's loaded up a sequential model, which is exactly what we want. But you're probably thinking, Nick, what the hell is happening here? I've got a model. How are we going to specify which layers? Probably the most useful thing when it comes to working with TensorFlow is that you can actually type in .summary after a sequential model, and it's going to show you what layers are actually available inside of that specific model. So here we can actually see that we've got a convolution layer. You can see that it's specified there. So if you see conv2D or conv3D or conv1D, these are convolutional neural network layers. We've also got a max pooling layer. So we could actually take a look at the outputs following the conv2D layer, but also the max pooling layer. We could do the same for this layer, this layer, this layer, this layer. If we're going to do it with dense, we need a little bit of tweaking. But for now, let's focus on the convolutional layers, because I find that that's where a lot of the time you tend to have to do a bit of debugging to ensure that your neural network is doing the right thing. Now, how do we actually go about getting these layers? Well, we can actually type in model. Let's actually just quickly make a comment here. So view the model summary. And what are we doing? So we are taking a look at our layers. So model.layers. So you can see there that we can actually grab specific layers from our neural network. Or right now, I haven't shown you how to grab them, but you can see that we can actually output all of the different layers. If I wanted to grab a single layer, I can actually go, give me layer 0. And this layer over here corresponds to this one here. So you can see that we've actually gone and done that. Now we can also grab it by name, but because I haven't actually defined the name, it's going to be a little bit crappy, but we can type get layer by name. Get layer, and then I think we pass through. So let's say, for example, we wanted this layer, conv2D, which is the first layer. So you can see that we're now grabbing that layer. If I wanted to grab this one, I can pass through the name to that. And I've passed through a space there, but you can see it's now grabbing that layer. So you've got a little bit of flexibility when it comes to actually grabbing these layers. We're not going to do it like this. We're going to use the regular slicing. So let's say, for example, we wanted to grab the first, 1, 2, 3, 4 layers, right? Actually, let's grab the first 3, because then we're still going to be outputting from a convolution. We can actually go and specify that we want the first 3. And all I'm doing is I'm passing through a colon and then the number 3. So this is basically saying, get me everything, or from the third position onwards, grab me everything behind. And because we start at 0, it's going to grab layers 0, 1, and 2. 0, 1, and 2. So you can see that we've now got the specific layers that we want. Now, we can actually store this, or we should probably store this inside of an intermediate variable. Now, if we didn't really want to, we could still actually do something a little bit unique. So we could type in Let's call it intermodel. Or actually, let's call it output. CNN model? I don't know. Yeah, let's call it intermodel. So intermediate model, right? And then we could set it past those specific layers, the model.layers. We could actually pass that through to the sequential API, which we brought in from up here. So if you've never seen the sequential API, I highly recommend you go and take a look at the image classification tutorial that we did, because it was super, super useful. And we actually went through a ton of stuff. Now, actually, rather than defining this as the intermediate model, let's actually call this intermediate layers. So we know that we're going to be storing the intermediate layers inside of this variable, right? So this represents the trained. Keep in mind, these are trained layers, trained intermediate layers. Now, what's cool about the Keras sequential API is that we can take these intermediate layers and push it into a new model. So we can actually take those intermediate layers and actually pass it through to the sequential model. Now, this is how you might actually go about doing transfer learning. You could actually take these layers and then stack on whatever else you wanted after the fact to be able to effectively transfer that knowledge from the existing trained deep neural network. Let me know if you want a tutorial on transfer learning as well. Okay, so we got our intermediate layers, so we can run that. So again, if we go and take a look at our intermediate layers, you can see that we've got all of our intermediate layers there. Now, what we actually want to do, because right now there's no real way to pass through some input, right? So there's no way to actually go and type in .predict. There's no way to actually go and output something as a result of this. So we can actually take those intermediate layers and wrap it inside of the sequential API. So we're going to create a new variable called intermediate model, and we're going to pass those intermediate layers to our sequential API. Oh, I'm going to tabbed. Boom, boom. All right, so this should be the intermediate model with trained existing layers, right? So now if we take a look, intermediate model, we now have it wrapped inside of our sequential engine, which means we can type in .predict and all of that good stuff. We should also be able to type in .summary. And we've now got an intermediate model. How sick is that? So this means that we can now load up an image and we can actually visualize it by passing, or visualize the outputs of this final output layer by going through this intermediate model, right? Which is super, super useful. So let's actually add a comment here. The intermediate model is now represented as just the just the X layers that we took. I put X because really we could change this, right? So we could grab 4 layers, we could grab 5 layers, grab all of the convolutional neural network layers. But for now, we're going to take a look at the last 3, and that is our intermediate model. Okay, what's next? We actually need to grab an image. So let's go and grab an image. Now, key thing to keep in mind is that our intermediate model is going to need images of a specific shape. So we can take a look at that. And this is sort of good practice as well, because if you're working with neural networks that you've never seen before, you're actually going to get the chance to see how to determine how to work with them, right? So I can type in intermediate. Let me bring that up a little bit. Let's minimize that. So I can type in intermediate dot input shape, intermediate model dot input shape. And this is telling me that the image needs to be of size 256 by 256 by 3. So if we're going to load up an image, we need to go and convert it to be 256 by 3. So it'll be 256 pixels. What is it? So rows height. So it'll be 256 pixels wide by 256 pixels high by 3 channels. I can never get which goes first, rows or height, but just know that it needs to be 256 by 256 by 3. Okay. So what do we want to do? First things first, we actually need to go and actually get an image. Now, I've got a bunch of images that were originally from the image classification tutorials. I've got this one here, which is a person which is happy, and this dude here, which is deep in thought, and I guess I would say probably not so happy. So we can actually load those in using OpenCV. And remember, we imported OpenCV up here, so import CV2, which means we can use the cv2.imRead function. Let's actually add a comment for this line here, though. Take a look. Determine required input shape. All right, so load image. So load the image, and we're going to load in the happy one first. So the file name is happy.test or happytest.jpg. So let's copy that. You could work with a bunch of different images as well. So we're going to call it image equals cv2.imread, pass through the full file name or the path to the file. Because we're working inside of the root folder, we can just pass through the file name and we should be good. And we need to resize it as well. So we're going to type in cv2.resize, and we're going to pass through our image, and we're going to pass through the new dimension. So it should be 256 by 256. I think that'll work. I can't remember if we need to pass through the channels. Let's try that. Okay, so resize.shape. All right, that's looking good. All right, so we've gone and done or written 2 lines of code there. So the first one is image equals cv2.imread, and to that we're passing through the full file path to our specific image, which in this case is happytest.jpg. And then we're taking that variable, so image, and we're passing that through to the cv2.resize function. You can see that this is going to here. And then we're specifying the new dimensions for that image, which is going to be 256 by 256. And then that variable is then going to be called resize. So we can see that resize.shape is 256 by 256 by 3, which just so happens to match the input shape of our intermediate model. So this means that we'll be able to take this image now, pass it through to our intermediate model and get some output. So if we actually do that, a comment for this last line, view the shape of the resized image. So what are we doing? We're making a prediction. Make a prediction. So if we type in intermediate model dot predict, and all right, I'm going to throw an error here because I want you to sort of see why we need to do a particular step. So if I type in intermediate model dot predict and pass through resize, this is going to throw an error. And you're probably thinking, Nick, what the hell? Like, we just went and resized this image to be the same as the input shape. Why we get an error? And if we go and take a look at our error, you can see it's saying input 0 of layer sequential underscore 1 is incompatible with the layer. Expected shape none, 256, 256 by 3. Let's zoom out. How did I zoom in? It should be, my bad. You're probably thinking, but we've made a 256 by 256 by 3, Nick. What is happening? Well, it's saying found shape. I hope my head's not covering that. Found shape equals 32? That looks like it might be a little bit wrong. 32 by 256 by 3? Might be transforming it. But anyway, it's saying found shape 32, 256 by 3. This is because we haven't gone and passed it through correctly. When we go and make a prediction using the .predict function, it is actually expecting you to be passing through a batch of data. So this means the first dimension will represent a whole bunch of images, not just one. This is easily resolved. We can just type in np.expand underscore dims and then pass through what dimension we want to expand on, which will be the first dimension, which is 0. Boom, now we've got a prediction. So that's a really easy fix, and that's the reason that we actually bring in NumPy over here. So if I type in intermediate underscore model dot predict and then wrap it inside of np.expand dims, I'm now going to get the correct shape. So if I actually show you this, right? All I'm doing is wrapping it inside of another set of arrays. So now we've got the batch size by the pixels, by the width, by the height, and then by the channel. So now we can actually pass it through dot predict. Perfect. Okay. So now if we actually store this inside of a variable called y-hat, it's common terminology when it comes to notation for a prediction, we've now got our prediction. So if we take a look at y-hat, we've got our outputs from our intermediate convolutional neural network. Pretty cool, right? So if we take a look at dot shape, the outputs that we're getting are 125 by 125 by 32. And the 32 is probably because we have 32 convolution or 32 filters in our final layer, which is exactly that. So you can see that our convolutional neural network layer actually has 32 filters, and we're getting the output of each one of those filters. So you can actually specify which filter that you'd want to actually go and take a look at as well. For now, we're just going to take a look at all of them because we're interested to see what is happening in the background. Right, so far, let's take a quick recap of what we've done. So we've gone and imported a bunch of dependencies, so iter-tools, matplotlib. We then went and loaded our model using the load model function from over here. I showed you how to visualize the models, and we can type in model.summary or intermediate_model.summary to do that. And this is pretty common if you're working with any sequential models in Keras. We then took a look at how we can grab specific layers, how we can pass those through to a new sequential model to be able to actually build up and use that predict function. Summary, you've sort of seen that before. Where are we up to? That just did a little quick weird skip. We can take a look at the input shape, and we know that none function base or that none space represents the number of batches that we're going to be passing through. We then went and loaded our image, and we went and resized it. Keep in mind, we can go and visualize our image using plot.imshow. This is our resized image as well, right? Right, so we can go and visualize that just by using plot.imshow. And you can see that we've got this weird coloration, and that's because OpenCV reads in an image as BGR. Matplotlib visualizes it as RGB. So we can fix that using cv2.cvt color. So this is almost like a color conversion function inside of OpenCV. And then we pass through the new color conversion code. So cv2.bgr, or actually, what is it? cv2.color, I think. Yep. And then it's BGR to RGB. Right, so you can see the color representation is a little bit more accurate there now. So if we take a look at the happy test image, even though it's huge, you can see the colors are the same, right? Cool. I'm showing you this now because it's going to come in handy, or quite a fair bit, when we actually go and visualize it in a second. So this is, what is it? So Viz, the resized image. Boom. Okay. Now, all that we want to do is we want to visualize the output from our neural network. So rather than actually just seeing that we've got outputs, we probably want to see what those actually look like. Now, they're going to be some sort of representation of this, but once it's passed through the convolutional neural network. So I'm going to write some code and then we'll break it down because there's a fair bit to come here. So first up, we're going to specify the number of columns and number of rows we're going to have in our visualization grid. So let's actually create this, a Viz Grid. And we're going to specify the number of rows. I don't know, we'll set that to 4. The number of columns, we'll set that to 4. So this means we're going to have a 4x4 grid. So we'll see 16 filters at the time, or at a time. You could definitely expand this out. It might get a little bit small, but you sort of got the idea. And then we're going to create the grid. So we can use plot.subplots for this. So we're going to call fig.ax equals plot.subplots. And then we are going to specify the number of columns. So ncols equals the number of columns, and rows equals the number of rows. It should be n rows. And then we want to pass through fig size. All right, so let's quickly break down what we've gone and done so far. So the first thing that we're doing is we're specifying how big our visualization grid is. Now, if we wanted to just visualize one filter at a time, we could definitely do that. Let's actually quickly take a look at how to do that first up. So remember, y-hat is, so we've got one filter, or we've got one output, but we've got 125 pixels by 125 pixels by 32. So if I actually went and said, grab the entire amount, or sorry, we don't want the shape. So if I went and said y-hat 0, type in .shape. So we've now got 125 by 125 by 32. Now, if I said 0 and then grab everything, and then grab just 1. So we've now got a pixel output, which is 125 by 125. I could actually output 0 here. Now, if I took that output and passed through to plot.imshow, let's try this. You can see that that is the output from one convolutional neural network layer. So this sort of gives you a lot of flexibility when it comes to visualizing those outputs. Now, we can see that it's definitely highlighted the teeth. So maybe that's an indicator that teeth is a really important determinant of determining whether or not something is happy or sad. We can take a look at another filter. So if I pass through .1 here, or just 1. So again, highlighting different areas now. So it looks like cheeks are being highlighted. Doesn't look like it's doing too much with the arms and whatnot. What about 2? Okay, so again, teeth, looks like it's highlighting the arm there. Let's zoom in a little bit more so you can see that. Again, we've got some different highlights. So it looks like the teeth again are being highlighted. What about 3? Okay, so again, teeth, looks like hair. We've sort of got the outline of hair. Teeth. So it looks like teeth might be a really important determinant of whether or not you're happy or sad. So again, teeth are being highlighted there. Looks like that filter is not really picking up all that much. That one might not be all that useful. Okay, so this one looks like it's outlining the outline of her body. So this might be very much focused on her body or the shape of her pose, for example. But this might take a little bit of time. So let's actually go and finish our visualization grid. And this is what I tend to do. So rather than doing one by one, which is still definitely possible, this actually sort of gives you the ability to visualize multiple outputs at the same time. So again, we've written num underscore rows equals 4, num underscore columns, and we've set that equal to 4. So we're going to be able to visualize a 4x4 grid. And then we're starting to create a subplot. And think of this just like a grid, right? So you're going to have multiple plots. And when you've got multiple plots, we're typically referring to those as subplots. So it's just multiple plots under one bigger plot. So we can refer to the figure from, so this is a matplotlib function. I don't really know why we call it figure, but I know that what's really important are the axes. So the axes represent each individual subplot. So we'll actually, when I create this, we'll actually get 16 different values inside of this AX value. So fig, comma, AX equals plot dot subplots. And then we're specifying the number of columns that we want in our subplot. So n cols equals num cols. So we're setting it to that. N rows equals num rows. So we're setting it to that. And then we're specifying the figure size, which is going to be 10 by 10. What we can then do is loop through each one of the outputs inside of our y-hat variable and visualize those individually. So let's go on ahead and do that. Okay, before we go any further, let's actually quickly take a look at what I've written there. So this was something that I was working on to make it, or to ideally try to get this into a single liner, and I was playing around with this week. Itertools.product effectively allows you to create a whole bunch of combinations from two different lists. So if you're trying to work out how to visualize the product of two different lists, itertools.product, super easy, right? So I can type in itertools.product. Pass through, I don't know, let's create two lists, right? So 1, 2, 4, for example. And then, I don't know, let's create another list, 5, 6, 7. So if we actually output the values, so vals, and then if we type in dot what, how do we get the next one? For val in print val. So you can see that we're actually getting every single combination that can be made between these two values. So every single permutation and combination, right? Which effectively allows you to do exactly what you need. So in this particular case, we need every single permutation of rows and columns. So we're going to have position 0, 1, or 0, 0, 0, 1, 0, 2, 0, 3, 0, that's it. Then 1, 0, 1, 2, 1, 3. So this will allow us to get all of the different axes from this AX value over here. And effectively what we're going to do is once we've got the specific position inside of our grid, we're going to visualize using ax.imshow. So I just wanted to sort of give you a little bit of background as to why we're doing this. Now, over here, what we're doing is we're just passing through the range for our number of columns and number of rows. So if I substitute these two values out, plug these in here, so what we've actually got are all of the different positions for our subplots. So that is effectively, what is it? Row 1, row 2, row 3, and row 4, so on and so forth. And then you've got the individual column positions as well. So that is that over. So that's pretty much explaining that. And then we're putting that into a list. And then we're enumerating so we get both an index and the AX index. So the index is going to be used to grab the values from our y-hat variable. So if we actually take a look, I can then go, let's do the entire thing, right? So we can type in enumerate, put this inside of a list, and then we are effectively getting an IDX and then AX IDX. So if I print out our index, so this is going to determine which position we want to grab from our y-hat variable. So if I actually went and said y-hat, and then we're going to grab the first value, all the pixels, also all the width, all the height, and then we're grabbing that specific index. So you can see we're grabbing the output from each individual filter from our convolutional neural network by doing this. Cool, cool. Okay, so now the last thing that we need to do is actually go and plot those out. So let's do that. And there we go. So we're now outputting the results from all of our filters. So we can delete this. We don't need that, don't need that. So you can see that effectively what we're doing is we're just visualizing a grid. So rather than doing it one by one over here, we're just outputting it a little bit more nicely. So let's quickly take a look at that last line of code. So what we're doing is we're grabbing the axes from over here. We're using our indexes to be able to grab each individual position that we want. So AX underscore index 1, I think represents, I can never remember which one's the columns versus the rows, but you sort of get the idea. Let's actually play around with this. So if I go number of columns 3 or 4, let's actually do 5, right? So if I go 5 and then let's say we grab more. So what is that going to do? Is that going to screw up? So we've now got a new, we don't have anything. So wait, 1, 2, 3, 4, 5. Okay, so that's worked out okay. What if I set this through to, I don't know, 4 and 4? What breaks first? Okay, so that looks like the 5 is referring to the column. So that means that the index value 1 is going to be, trying to think now. So let's actually take a look at the matplotlib documentation subplots. So what do we have here? So matplotlib subplots. And we have X and, no, wait, hold on. So we've got the two, we go subplots in 2 directions. So we've got, when stacking 2 directions, the returned axis is a 2D numpy array. If you have set parameters for it's handy to iterate over some plots using 2D grid for AX. This really still doesn't tell us one. AX1, AX2. So AX1, AX2. So that is going to be, so the first set of values are going to be the rows. So AX1, AX2 represents the rows. So row, row, green, red. And then the second 2 values represent the columns. Okay. All right, cool. So this means that the first 2 values are actually representing the rows. So let's actually take a look at AX. Right. So this is row 1. This is row 2. This is row 3. This is row 4. Right. So if I went and said, grab this, and made it num rows 10, that means that we should effectively get 10 values in that first set of arrays, so 4 columns. So if I go and type in AX now, there you go. So we've now got 10 different rows. Exactly that. All right, cool. That's making more sense. It's killing me that I couldn't remember how that worked. Okay. So then what we're doing is we are effectively grabbing our, so if we went and said this first value to the number of, what is it? Number of rows. So num rows, num cols. Then we, ideally we should be switching these, right? Because we want to grab the first, which would be the rows. Sorry, I'm probably confusing you guys a whole heap more, but I want to make sure that this makes sense. Okay, yeah, so that still works. Right, okay, so if you're going to, the first value that you want to pass through to your AX underscore index is going to be the number of rows or the position of the rows. The second value is going to be the position of the columns. So just keep that in mind. But again, you can play around with this, see how it works and go through it in a bit more detail. So I think I switched these around. So yeah, so originally I had columns and then rows, but now rows and columns sort of makes more sense because the rows are the first values that you're going to get out of this AX value. But again, I figured I'd show you what that effectively looks like, and that is how to visualize the intermediate outputs of a CNN layer. So I know I sort of went through a bunch more detail there. It doesn't look all that great. You can obviously make this plot a whole heap bigger by changing this fig size value. I think if you go 20, There you go. So you just got a bunch more space around it, but that at least allows you to see it in a little bit better detail. But let's take a look. So again, very much focused on the person's teeth being white, because that is obviously a key determinant of you smiling and you sort of being happy. Now we could obviously pass through a whole different image. So if we went and grabbed our sadtest.jpg, sadtest.jpg, so that's our sad dude. Let's see what that's visualizing. Okay, so again, it's sort of outputting his body. Let's take a look through the subplots. There's no real key feature here, apart from the fact that it's not really highlighting the mouth. So, I mean, it sort of at least shows that we're getting different outputs from our CNN layers, but there's no real sort of trend here. Whereas when we were taking a look at a happy photo, it was very much focused on that person's mouth. So again, this is a really unique way of actually taking a look at how your CNN layers work and delving into that a whole bunch more. Hopefully this has been useful. Let me know in the comments below if you like more sort of tech or deep learning deep dives like this. I found it useful because I'm using it quite a fair bit at the moment, but that sort of gives you an idea as to how it all works. Now, quickly recap. So we went and brought in a bunch of dependencies. We went and loaded our existing H5 model. And if you want to grab the one that I was using, just grab image classifier from the previous image classification tutorial. We then took a look at the summary, the intermediate layers. We took a look at our summary over here for our intermediate model. We then loaded up some images, resized them, and then we went and took a look at how we can make predictions with our intermediate model. And last but not least, how we can visualize our output grid. And that about wraps it up. Thanks again for tuning in, guys. Peace.
Hold up guys, Editing Nick here. So I just realized that I didn't show you how to go and pass through a different number of layers to the model. So let's jump back on over to the computer and do that.
Right, so the last thing that I wanted to quickly show you is how you go about doing this if you wanted to visualize a different set of layers, right? So keep in mind that the thing that we were looking at up here was this layer. So we were looking at conv2d_1. So that was the core layer that we were currently looking at a point in time. So what would we need to do in order to visualize a different layer or the outputs from a different layer? Well, all we really need to do is change the number of layers that we're grabbing as part of our intermediate layers variable. So I could go and grab, let's say we wanted to grab the outputs after a max pooling layer. So I could pass through the index 4, which would mean I'd grab everything before index 4. So if we take a look at intermediate layers now, you can see that we're now ending up at this max pooling layer. And again, it's pretty much the same step. So we can go and run through the next couple of lines of code. And now you can see that because we've gone and applied a max pooling layer, it's a little bit more pixelated, because that's effectively what a max pooling layer is doing. It's grabbing the max value from a specific region and sort of condensing it down and condensing the amount of information that's being passed through to the next layer in our artificial neural network. So if we now go and visualize that, again, you can see that it's sort of emphasizing the mouth and highlighting the mouth a whole heap more. Now, again, we can go and change this and take a look at our sad test image. And what have we gone and done there? We just got to get rid of the second.jpg. So again, it's visualizing our dude. What's it highlighting here? Maybe his t-shirt, maybe his hands. Looks like it's highlighting in the background. So again, no real sort of pattern or trend there with our sad test. Now, again, if we wanted to go and get a different layer, so you really just need to change the index for the specific layers that you're pulling. So let's say we wanted to grab, I don't know, this layer over here. So conv2d_2. So this would be 0, 1, 2, 3, 4. Yeah, 4. So we'd effectively be grabbing everything before index 5. So if we go and change our value inside of model.layers, re-plugging in my zoom so I can zoom in. So really all we're doing in this particular case is we're changing the index that we're passing through over here. So remember, if we started off with index 3. If we want to go and grab the next layer, we can grab index 5, so on and so forth. So if we go and run this now, so you can see that we've now got 0, 1, 2, 3, 4 different, or the fourth layer effectively, fifth layer, but fourth index. So if we go and take a look at our visualization, you can see that that's almost reduced it to nothing, right? So if we go and take a look at our output, so it looks like we're throwing an error. And why are we getting, so we've got 0, 1, 2, 3, 4. Oh, okay, so right now we're trying to visualize 20 different, this is actually a good error, right? So right now we're trying to visualize 20 different filters, so 4 by 5. Now, if you keep in mind that the last output layer that we had only had 16 filters, so hence we're getting that error. So what we need to do is readjust it. So if we go and change that back to 4 over here, we should be good to go. And there you go. So you can see that we're now visualizing all of those different layers. And you can see that some of the kernels are actually returning back absolutely nothing. So nothing, 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 nothing. That's okay. It might just be an indicator that because this particular image doesn't have certain features that it's looking at identifying, it's not returning anything back. Now we can try this with happy test or a happy image. Okay, so you can see that mouth is being highlighted in one, but over here it's looking very much at the pose of the person's body. So maybe it's found that pose is just as important in this particular case. This is where skip connections are really, really useful because you're still able to maintain certain information from previous layers in a specific architecture. But I figured I'd quickly show you how to go and change the number of layers that you're able to visualize. So if you want to dig into it a little bit more, that you definitely can. That about does wrap it up this time. Cheers.
Thanks so much for tuning in, guys. Hopefully you enjoyed this video. If you did, be sure to give it a big thumbs up, hit subscribe, and tick that bell, and let me know what you thought of this almost sort of technique short. I found that it's really, really useful if you're building deep neural network architectures and you're just trying to work out, have I got the right architecture? Have I got the right activation? Do I have enough complexity in my neural network to be able to handle my specific problem? Anyway, thanks again for tuning in, guys. Peace.